Welcome to my Easy Statistics. In this video, I am going to discuss about MANOVA. MANOVA stands for Multivariate Analysis of Variance. It is a statistical technique used to analyze the difference between the means of two or more groups on multiple dependent variables simultaneously. So I am taking a case where we have multiple dependent variables like English marks, mathematics marks and science marks, and we have one independent variable which is called teaching method, and this teaching method we have A, B and C teaching methods. We want to investigate, is there any significant difference between teaching methods towards each dependent variables. So we have taken 96 individuals and 32 participants for each teaching method. I'll show you the data first, then we will discuss the methodology. So in this data you can see we have teaching method which is an independent variable, and English marks, mathematics marks and science marks, these are the dependent variables. And you need to understand that when we do this MANOVA, we have more than one dependent variable. If you have only one dependent variable, we are going to do ANOVA. If you have more than one dependent variable, we are going to do MANOVA. And this a dependent variable is a scale data. If it is nominal data or ordinal data, we must not do MANOVA. If it is scale data only, we need to do MANOVA. So we have three dependent variables and one independent variable. Now let's start the analysis process. Before doing analysis process, there are some assumptions for MANOVA. The assumptions are: first one, independency. Each participant should take part in research only once, and their involvement should not influence the participants of the other. This is called as independency condition, the first condition. Second assumption is normality. They must be a univariate and multivariate normality of the distribution. We have dependent variable which is a scale data, so we need to do univariate normality test and we will do multivariate normality test, and the system says this normality assumptions must be fulfilled before doing the MANOVA test. Third condition is multicollinearity. There must not be a high correlation between dependent variables. If there is a high correlation, then it can complicate the interpretation of MANOVA results. So multicollinearity should not be there between the dependent variables. Fourth one is cell size. The number of cases in each group must exceed the number of dependent variables. If the cell size is greater than 30, then MANOVA demonstrate robustness against violation of normality and equality of variance. So it is recommended to have high number of cases in each group. So we need to have more number of participants for doing this MANOVA test. The fifth assumption is homogeneity of variance, covariance matrices. Similar to the homogeneity of variance assumption in ANOVA, MANOVA must have homogeneity in the variance covariance matrices across groups. So now we are going to do normality test, multicollinearity test and homogeneity test on the dependent variables, and let us see whether we are able to fulfill this assumption or not. Once we are done with this normality test, multicollinearity test and homogeneity of variance covariance matrices, then we will do the MANOVA test. So we'll start first with normality test. So we'll go here. We need to do normality test individual for each dependent variable. We'll do for marks, English marks, mathematics and science marks. Let's analyze. Analyze in this descriptive statistics, and within this we need to do again descriptives and explore. Now select all the three because we want to do normality individually for all the dependent variables. So we'll select English marks, mathematics marks, science marks as a dependent variable. Click plots. In plots, select the normality plot with the test and click continue and click OK. In this output screen, first we will be seeing the test of normality. In this test of normality, we have two type of tests, Kolmogorov-Smirnov test and Shapiro-Wilks test. So which test we need to use for checking the normality? For that purpose, we will see this normality. A normality test is a statistical method used to assess whether a given data set follow a normal distribution, that is a bell curve, is a symmetrically probability distribution commonly observed in nature. So which test to use? Shapiro-Wilks test or Kolmogorov-Smirnov test? Shapiro-Wilks test is generally preferred when the sample size is relatively small to moderate. Typically recommended for sample size up to 50 to 200 observations. If a sample size is between 50 to 200, then we are going to use Shapiro-Wilks test. If a sample size is more than 200, then we must use Kolmogorov-Smirnov test. So I am clear. Shapiro-Wilks test is used if the sample size is below 200. If it is more than 200, that is a large sample, we are going to use Kolmogorov-Smirnov test. I already said in our data we have 96 respondents. So we need to do Shapiro-Wilks test must be checked for the normality. So let us go to the output screen once again and see the test. So Shapiro-Wilks test we need to check. For English marks, if you see, the significant value is 0.071. Mathematics mark 0.019 and science mark 0.032. So is the normality there? So for that purpose, first we must see is null hypothesis. The null hypothesis specifies the data follows a normal distribution. If the p-value is greater than 0.05, we will fail to reject the null hypothesis, suggesting that the data is normally distributed. Means if the significant value is less than 0.05, data is not normally distributed. If the significant value is more than 0.05, then the data is normally distributed. What is this value 0.05? 0.05 is called as a significant level at alpha is equal to 0.05. Confidence interval 95%. Significant value will be 0.05. So since the null hypothesis states that the data follow a normal distribution, and if the significant value is less than 0.05, we reject and say that data is not normally distributed. If it is 0.05 and more than 0.05, we can conclude that the data is normally distributed. So if you see the output screen, in this output screen for English marks, the significant is 0.071, means for English marks the data is normally distributed. For mathematics marks, the value is significant value is 0.019. So the data is not normally distributed for mathematics marks. For science marks, the data is 0.0324. It is also normally distributed. So the first assumption says that data must be normally distributed. If you see for English marks and science marks, they are normally distributed. But mathematics marks, the data is not normally distributed. So what we will do? We will exclude this mathematics marks from the analysis and we will see for English marks and science marks only. Now since we have did uninormality for each subject, now we are going to do multinormality combined for English marks and science marks. I'm excluding mathematics marks because we have come to an assumption that the data is not normally distributed. So we will do now directly the multivariate normality test only. For that purpose, you need to go to analyze. In analyze, we are going to go for regression. In regression, go to linear. Now take the dependent variable as ID. ID is nothing but sequence of respondent numbers. And take English marks and science marks. And here you can go to statistics. In statistics, we can say collinearity diagnostics. Click continue and save. In the save button, select Mahalanobis distance. Only this one I am going to show you. Only the important one I am showing you, Mahalanobis distance. Click continue and click OK. Now when I click OK, in the data we will be having Mahalanobis distance is a value. Now make it descending. So when I click descending, we are going to get the highest value on the top. This is 10.19524. This is Mahalanobis distance. Now, how we are going to know whether we have multi-normality or not? For that purpose, we need to see chi-square test. We need to see the table of chi-square values. Now, degree of freedom is a number of dependent variables. Here we have two dependent variables. And p-value is 0.001. At this point, if you see, the chi-square value is 13.82. But what is the maximum Mahalanobis distance we got? We got 10 point, the first value, 10.19. But chi-square value, we can see in the table, we are getting as 13.82. So the Mahalanobis distance, maximum Mahalanobis distance, if it is less than the chi-square value, we can consider that multi-normality is there for the data. Multi-normality is there for the data. In case the maximum Mahalanobis value in the data is greater than the chi-square value, then we can come to a conclusion saying that the multi-normality is not there. So in chi-square also, please understand, degree of freedom is, I am taking as 2 because we are considering how many dependent variables? 2 dependent variables. And p-value we are going to take as 0.001. This is a standard one. So always when you are checking this chi-square value, please take standard value p is equal to 0.001. At this case, we have 13.82. This is called as a chi-square value. And in the data, after you get the Mahalanobis distance value, do it sort it by descending. Then you get the maximum value on the top. See the maximum value. If this maximum value is less than the critical value, we can conclude that there is multi-normality. If it is more than the critical value, there is no multi-normality. So in our case, now we are fulfilling the assumption that we have multi-normality. Okay, we have English marks and only science marks. Mathematics marks we have not considered because when we did individual univariate normality, means single variable, we have not got the required normality for mathematics marks. We got only for English marks and science marks. So for English marks and science marks, I did the multivariate normality. When I did this multivariate normality, now I came to a conclusion that there is multivariate normality. So my assumption is fulfilled. So we have different assumptions are there. The first assumption we have is normality, where we have discussed about univariate normality and we have discussed about multivariate normality of the distribution. So normality is done. Now let us discuss about multicollinearity. What is the meaning of multicollinearity? Checking whether there is high correlation between the dependent variables. For that purpose, we are going to do regression analysis once again. We must go to analyze. in analyze, regression, in regression, linear. In this, select a dependent variable as ID numbers. It's only sequence numbers, nothing to do with that one. And a dependent variable is English marks and science marks. Go to options. In options, no, not options. Go to plots, not plots. Go to statistics. In statistics, select collinearity diagnostics. This one you must select. Click continue and click OK. Now in this we are going to see VIF value, variance inflated factor. This value must be less than 10. If it is less than 10, we can conclude that there is no multi-collinearity between the dependent variables. We can see VIF value for English marks is 1.053 and for science also 1.053. So these values, if it is less than 10, then we can conclude that the variance inflammatory factor less than 10, we can conclude that there is no multi-collinearity problem in the data. So we have did the second assumption also. We have tested that whether multi-collinearity is there or not. Now let us do the next method, which is called homogeneity of variance. So this we are going to do in the MANOVA analysis only. So let us start the MANOVA analysis now and do the test of homogeneity assumption also. So for doing MANOVA, we need to go for analyze. In analyze, we are going to go for general linear model. In this general linear model, multivariate. In this dependent variables, we are selecting as English marks and science marks. We are not taking mathematics marks. And the teaching method we are taking as fixed variable. And in the options, select descriptive statistics and select this homogeneity test. Okay, this homogeneity test is going to give us about the homogeneity of the variables. Okay, so we are going to select only two things: display descriptive statistics and homogeneity test. Click continue and click OK. That's it. This is a simple way I am taking. I have selected two dependent variables, English marks and science marks, and fixed factor only we must select the teaching methods. We have three teaching methods: method A, method B and method C. And I have selected only options. In these options I have selected only descriptive statistics and homogeneity test. Click continue and click OK. Now we can see the number of cells. You can see 32, 32, 32. This is also one of the assumptions. We said number of respondents in each group must be greater than the dependent variables. We have two dependent variables, so it should be more than 2. But we already said if it is more than 30, it is the best one. So we have 32, 32, 32 equal in each of the methods, in each of the group. So we are fulfilling that cell count also. Next we are going to see homogeneity. For homogeneity we need to select, you must see this one, which is called as box test of equality of covariance matrices. In this we need to see the significant value. This significant value is 0.242. So let us see how to comment this one, how to interpret this one. For this purpose we will go to multi-collinearity. Yeah. Yeah, homogeneity of covariance assumptions. The assumption is that the covariance matrices of the different teaching methods are equal. This means that the relationship and variability among subject marks are same for A, B and C teaching methods. So the box M test evaluates whether we have enough evidence to reject this assumption. If the test indicates a significant difference, it suggests that at least one teaching method have a covariance matrix that is different from the other teaching methods, implying that the variability and relationship among subjects' marks are not equal across three teaching methods. In simpler terms, the test checks whether the way students score vary and relate to each other in mathematics, science and English subjects is consistent across all teaching methods. If there are significant difference, it implies that the teaching method may have different effect on the relationship and variability among the subject marks. Okay, don't get worried about so much discussion. It's very simple. We need to see this null hypothesis. The covariance matrix are equal across teaching methods. This is a null hypothesis. If the p-value is less than 0.05, we are going to reject. Okay, right? If the p-value is greater than 0.05, we are going to accept that covariance matrix are equal across the methods. So we can see in the data we have the value of box M. Method is 0.242, which is more than 0.05. So we are able to fulfill the assumption that there is equality of covariance matrices in the data. So we are able to fulfill the fifth assumption also. What is the assumption? That equality of covariance, that is homogeneity, is there in the data. The significant value must be greater than 0.05. We got 0.242, which is more than 0.05. So homogeneity of variance is there in the data. So this is a really good thing. So we are able to fulfill all the assumptions. We are able to fulfill all the 5 assumptions. What is the first one? Independency. Next one is normality. Third one is multicollinearity. We already discussed multicollinearity with VIF. Okay, cell size I shown you, we got 32. And homogeneity of variance, covariance matrix also we have discussed. That box M significant value must be greater than 0.05. So we got 0.242, which is more than 0.05. So there is multicollinearity problem is not there, homogeneity is there, normality is there, univariate normality is there, multivariate normality is there in the data. Now let us go for the discussion of MANOVA. It starts with 4 important tests. They are Pillai trace, Wilks lambda, Hotelingen trace and Roy's largest root. So we'll discuss about each one and we'll discuss in which condition we are going to take which method and how to interpret it also.